Hey guys, welcome back to AlgoYogi. We are doing graph series and our next problem in the list is find all possible recipes from given supplies. So let's go to LeetCode. It's a really interesting and creative problem, I would say, because it does resembles with course schedule 1, course schedule 2, but just like how it's all about finding patterns. This definitely fits into that criteria that, like, if you have solved course schedule 1, 2, and 4, you will definitely be able to solve this, or at least be able to find the resemblance to those problems. So let's get into this problem. You have information about n different recipes. You are given a string array called recipes and a 2D string array called ingredients, and at the ith recipe has the recipe basically value, recipe name, and you can create it if you have all the needed ingredients which are listed at the ingredient array at the ith position. So for the recipe at ith position, there are listed ingredients inside the ingredient array at the ith position. A recipe can also be an ingredient for other recipes. Really important line here, really important line, because this recipe, so there are listed recipes in our recipe array, and maybe once a recipe is created, that recipe could be an ingredient for next recipe or a recipe that came before it. That's also we have to understand, such that that also becomes the supply. We'll have to provide that recipe as an ingredient for other recipes. Really important line. So ingredients at ith may contain a string that is in the recipes. You are also given a string called arrays, supplies, containing all the ingredients that you initially have, and you have an infinite number of all of them. Return a list of all the recipes that you can create. You may return the answer in any order. Note that two recipes may contain each other in their ingredients. Well, we have already talked about it. So let's get into an example to understand this problem and also how to approach it. And I already said it, it's like really one of the it definitely falls into the pattern of course schedule problems. All right, so we are given recipes, ingredients, and supplies. Based on these supplies, we have to create an answer. So this is my supply list, and I have to create an answer list where for each of these recipes, I will be storing a Boolean value, so true or false, which will say that if I can create these recipes based on the ingredients they require, if those ingredients are present in my supplies. What a beautiful problem, what a beautiful problem. And I've just really summarized it so well, and I think it just clicks. How it clicks, let's get into it. So what we're trying to do is we are trying to create an answer array where basically for ith, so if this is the 0th and first recipes, for these recipes we'll be creating a Boolean answer if we can create those recipes. So let's talk about first recipe, which is bread. For bread, what do you need? So for bread, you need basically these two ingredients. This is basically in your ingredients list. These two material you need to create bread. But do you have these ingredients? Well, we'll check our supplies. We'll check our supplies. So it's supplies that's going to tell us that if you can make that particular recipe. So yeast, yes, it is present. Is flour present? Yes, flour is also present. So that means you have all the ingredients for the 0th recipe, which is bread. So you can create bread. So that's why you're going to mark your answer true for bread. How about sandwich? Can you create sandwich? Well, what are the recipes for sandwich? By the way, because you have already created this bread, so what you're going to do is you'll take this recipe and also append it to your supplies list. Why? Because you have already created this recipe, and those recipe, that important line basically fits in here. So what I'll do is it will become a recipe for other recipes. So I will add this bread which I just created using yeast and flour to my supplies now. So let's go over sandwich. Can we create sandwich? So we are done creating bread. So this is done, by the way. Can you create sandwich? So for sandwich, what do you need? You need 2 ingredients. These two, which is bread and meat. Do we have meat? Yes, we do. We have meat right here and we have bread right here. We just add it to our supplies. Awesome. So you can definitely create sandwich as well. So what you'll do, you'll mark true in your answer. True at the basically for a second recipe. So this is what you are returning. Now, how do we go about solving this problem? Well, we understand what we got to do, how we gonna form our answer. How do you check if you can create a recipe through its ingredients? Check in supplies. A recipe is ready, add it to your supplies list. So this was a brute force way of approaching its solution, and you can directly write it. But since this problem falls into, I already said it's kind of like a course schedule problem, and it falls really well into our graph series. So what we'll do is we're going to solve this problem using DFS in such a way that these recipes will be basically, first we'll be creating like a graph where each recipe is basically, each recipe in our graph adjacency list has its neighbors, all of its ingredients, require ingredients into its neighbors list. So let me show you how. So let me clean up these things and then let me show you how we are going to do that. So we will create, I'll call it recipe, recipe. So I'll call it recipes to ingredients dictionary. So what are our recipes? Well, we have bread. So bread. So these are the kind of the neighbors I'm creating. So for bread, you will have yeast, and you will have flour. So these are kind of neighbors, and these, if you consider all of them as nodes of a graph, so this is how you can represent. So for bread, let me write it like here. For bread, if this is a node, well, it basically has 2 requirements. What are those requirements? Yeast, and this is a directed graph, by the way, because you can for creating bread, you need yeast and flour. So there are outgoing edge from bread to yeast and flour, but you can't create flour from bread, right? You can't create yeast from bread. So that is why it's a directed graph, and here it's flour. Now for our second recipe, it's sandwich. So for sandwich, we need bread, and we need meat. So I will add here sandwich right here. So this becomes my another node, and the reason I'm creating on the top is so that you can see this structure, that sandwich needs bread and bread needs yeast and flour, and at the same time the sandwich needs another ingredient called meat right here. So it will need meat. Now you can see we have this graph created for us. Just looks a little bit like tree as well, but that's how even the course schedule would look like a tree. So now we have this graph created with us. It's all about traversing this graph and finding what all recipes are possible depending on if there is no cycle or interdependencies between these recipes, such that you can't like really create them. So and if for the recipes that dependency doesn't exist, that cycle doesn't exist, then we are going to add it, basically find our answer. So here what I'm really trying to say is we will be basically going over these recipes now, and will be for each of these recipes, we will be running a DFS inside our graph that we just created, and see if you can visit this. Basically, if you start your traversal at these recipes, so if I'm sending this node, I will be able to find this inside my recipes to ingredient list, and I will be able to visit, if I'm able to visit all its neighbors without getting stuck in any cycle. All right, and if you can do that, if you can reach to these terminal nodes where these nodes do not have any dependencies, which also means these lie in your supplies. So let me also clean this up, because this was not part of the supplies initially, right? It was not part of the supplies. It will become a supply, because in DFS what will really happen is, let's say if these two orders were switched, I'm sure that that confusion is still in your mind, that how, if initially you created bread, and bread is a supply for sandwich, and that's why you were able to make sandwich. But what if these two were switched? So if I just put sandwich right here and bread right here and sandwich in the first place, then what do we do? What do we do now? Well, it will not make any difference. Why? Let me show you. So first we'll try to do a DFS on sandwich. Okay, so what do we do? Well, we'll install our traversal at sandwich. Sandwich needs basically bread and meat, so it will try to look at supplies. Well, do you have bread? Well, it doesn't. That means, first of all, we are visiting sandwich. Initially we are going to mark sandwich that we cannot create it, so we'll mark it at false initially, and then visit all its neighbors, and we will only mark it true if you can successfully basically visit, or in this case can make those recipes, because these are recipes in itself, although they're part of supply right now. So first we will mark it initially false, and then we'll try to visit its first neighbor, which is bread. But we're going to check, does supply has bread? Well, it does not. That means we are going to run DFS on bread. Then that means we are trying to create bread first, because it's a dependency for my sandwich. So I will try to run DFS on bread. First neighbor, yeast, is it in my supplies? Yes, it is. That means it will return true to bread. Second neighbor, flour, in my supply, return true. Bread returns true to sandwich. Now sandwich has true from bread. It's gonna go to its second neighbor and ask are you in supply? Yes, it is. Yes, it is in the supply. So that is why it will return true, and it will be marked true now. Initially we did mark it false, and the reason is we have learned it in basically course schedule. What if there was a dependency from bread? There was a dependency back to sandwich. If there was a dependency back to sandwich, that means when I was trying to explore sandwich, then I will come to bread. And in case maybe this is the last edge I'm trying to explore, then I will come to bread. I will basically get true, return from my flour and yeast, and then I will try to explore its last neighbor, which is sandwich. But this time that is the reason I marked sandwich false, such that when I was trying to explore sandwich from bread, then I see a false which says that there is a cycle. There is a cycle. That is why you cannot complete this. So you will return false. So this will return false here. This will return false back to sandwich, and sandwich will be marked false. Although in that scenario, while creating our answer, we will basically mark at least bread. Bread will be marked true. All right. So that will be it. I think now we have understood. The concept. So let's write down our solution, which is going to be pretty easy. Let me rearrange our file here. All right, looks neat. Okay, so as I said, we'll create a dictionary, recipes to ingredients, recipes to in ing, and initially it's going to be empty. Then we are going to fill this for let's say what we're doing is for I in range length recipes. So recipe, this is like graph, this is the adjacency list or graph adjacency list. I'm just naming it differently this time. So for this, since it's a dictionary, it's going to store for the recipes key. So I'm just giving it that name at the ith position, and I'm append, what are we appending? All the ingredients, all the ingredients. Append this list of ingredients, so this should be basically, it should become I guess a list. I guess we can append the entire list, I think. So I will append this list. I don't have to basically explicitly tell this. So append, or maybe we don't need to append it because this will only occur once. So I will just provide this list at the ith position. So that will be all. Awesome, looks pretty good. Then we will be writing our DFS here. But before we do that, as I said, we will have this set of all the supplies, so that we can, in constant time, we can check what are the supplies available for us. So let's say I'll just say supplies set. It will be set, and I will just send in all the supplies. At the same time, I want to have a dictionary for basically, if I'm visiting something, then I should be able to mark those if I were able to create those recipes, right? So I will have this I'll call it dictionary. So I'll call it can cook dictionary. This can cook dictionary, where we will be initially, if we are visiting some recipe, it's under process, then I will initially mark it false, such that later, if maybe there is a scenario where there is a dependency, so either I can come back and look at it. So when I write DFS, you will be able to see like what I mean. So here, in place of recipe, I'll just put, it will be sending in recipe. Okay. Initially, let's put pass, but let's create our answer. Answer will be an array. And for recipe in recipes, and if DFS recipe, if this returns true, then we can append it to my answer. So answer dot append true. or else answer.append, sorry, answer.append, not recipe, answer.append false, right? All right, so let's write our DFS here. So it's getting a recipe. If let's say if this recipe in my supply set, if it's in my supply set, which means it's already prepared, then I can return true. So return true. If it's not in my this recipes to ingredient list, if this is not in my recipes to ingredients list, that means I didn't actually have that recipe and all its ingredients. So basically it's not even part of my recipes, even what I'm trying to find out. So if this recipe not in here, then I will just return false. Here I'm going to explore, let's say if this recipe is not in my supply, this recipe is in my although recipe thing, that means it has some supplies dependencies. Then what I'm going to do is, if this recipe, I've already checked, by the way, like if it is in my supply set, then I'm already returning. So if the recipe is not in the supply set, that means it's not in the supply set, that's when it will come to this statement, and it will try to check if that recipe is not even part of our recipes to ingredient list. We don't even like have that in my recipes. Then also I will return false, basically, because it's not even part of my initial recipe list, because even that recipe to become an ingredient for the other recipes, it has to basically process, right? So if it's not even in my recipe list, I can't even create it. So that's why I will return false. Otherwise I will have can cook, and in my can cook I will mark for this recipe initially, because yet I cannot create it yet, but that doesn't mean I'm temporarily marking it false. Okay, why? Because I will go into all the ingredients that are listed here in this those are its child, basically, right? Those nodes are neighbors or child, you can say. So I'll just say I'll call them node, or I don't know, ingredient. So I'll just call the ingredient recipe in recipes to ingredient, and I will put in that recipe right here. So this will give me all those recipes, and I can just check if this DFS, I will be running a DFS on it. It will either give me true or false. So if it gives me not DFS recipe, instead of recipe I'm sending this right here, then I will return false. Otherwise I must have processed this entire thing, all these ingredients. That means this thing right here, we were able to find all its ingredients in either my supplies, or I might have created that through here. So I will mark this true, and I will return I can return true, or I can return this can cook. All right, can cook. And by the way, I made a mistake here. So this thing right here, I've also explained it in as part of the conceptual part, where I was actually saying that while creating our answer, what we were doing is we were creating the answer like this. So here we had true and here we had false or true. But actually I was saying it, I had a course schedule in my mind. I'm not giving an excuse, but the answer here is not any different. It's just if it returns true for that recipe, let's say our DFS returns true for that recipe, so I will just add the name of recipe. So for this, let's say sandwich, if this returned true, and in this case, if this edge doesn't exist, yes, of course it will return true, because I can create this. And then for bread as well, it will return true. So this will be the, oh my god, I again made that mistake. So I will just, instead of that, I will just add the name sandwich, and then for bread also I will add the name that. So this will be the answer. So we will make that fix right here. I don't want to, I don't want to go with that wrong approach. So here, right here, answer will be not true or false or anything, just the name of this recipe. So this recipe, all right. So if this returned true, then add the recipe to your answer, and finally you return your answer. So return, you can't see the code. But why can't you see the code? I thought I had it done nicely. So return answer. Awesome. I'm just trying to see how far can you see. Okay, you can actually see most of the code when I type it. Okay, I'll make that fix though, that you can see entire thing. So now I would say now I think we are good. Let's run it on our example. Awesome. So let's submit it. Yes, I knew it. Actually, this memoization, we have done it, but we have not used it. So if this recipe in basically in this can cook, then that means either we have evaluated as true or false, just like here, either we have returned it false or true, and that is why I will basically have this marked. I will have it return. So this should return can cook, and this recipe. And by the way, instead of returning this, I think I should mark in my can cook this particular recipe as false also. So right here I should mark it false. That I forgot, because if it's returning false, that means it should go into my memoization can cook and should be marked false. So I'll just say false, and instead of this false, to keep it nice, the return statement nice, because here also I'm returning the same thing, then I can have both of them return the can cook and that value in can cook. Now I think it should be all good. I should submit it, and hopefully yes. So this is the entire code. Does not look very clean, so I'm gonna clean it up so that you can see all the code together, all of it. Nice. Okay, now we have all the code, all of it together, just like this. Let's write down the time and space complexity. So for time complexity, let's go over this. What we are doing, we're going over all the recipes. So let's call R is the number of recipes, and for that recipe we are going through we are running DFS on this recipe, and that recipe is going through all the other ingredients and recipes. So at the end of the day, what we are doing is visiting basically all the ingredients and recipes. So I would just say it will be big of R is the total number of recipes, because we are running DFS for all of them. And let's say if there are R number of recipes and there are S number of supplies, because we are kind of treating everything as part of the node, right? And this DFS is taking big of n time of complexity, because it's only visiting all the nodes just once, and also we are memoizing things in my can cook. So we are not repeatedly running DFS on each recipe. At max, I might be running this, whenever I'm calling it on all the recipes, but they must have been either available directly in supply, or they have been marked in can cook either true or false, or they have or they're not part of the recipes to ingredient list itself. So at max, it's I would say it's R plus S. So R is the number of R is I'll say number of recipes, and S is number of supplies. Right. Then for space complexity, it's also going to be same, because we are storing everything inside my dictionary. So dictionary, although for one key, it's storing all the ingredients as well. Yeah, I mean, this supplies thing, you can call it also ingredients. Yeah, this you can call it ingredient as well. So that will be all, and I will mark this problem solved. It's a pretty long video. Mark this all. So see you guys later in the next video. We have a couple more problems in graph remaining.